Hello, everyone. Welcome back. Good morning, good afternoon, and good evening, depending on from where you are joining us from. We are coming to you live from REMAS 2022 from Las Vegas. I'm Suman Devnath. I'm a principal developer advocate focusing around data engineering. And I'm super excited to have my co-host, Brian. Why don't you introduce yourself?
My name is Brian Terry, and I'm a senior developer advocate on the CloudFormation team, and I'm super excited to be here. So if this is your first time joining us, welcome.
Excellent. And we are going to talk about route optimization using Amplify Geo, API Gateway, Lambda, and location service. And that's quite a lot. And to help us with that, we have our guest, Matt and Shreyas. Why don't you introduce yourself?
Yeah, hi. My name is Matt Nightingale. I'm a startup solutions architect at AWS, specializing with Amazon Location Service.
And hey everyone, my name is Shreyas Subramanian. I'm a principal machine learning specialist. I have a background in optimization and machine learning. And shout out to everyone out there.
Excellent. So I think we have quite an exciting demo to follow up. But before we get started and dive deep, why don't you tell us what we are going to talk about today?
Yeah. So the solution I'm going to present today is for serverless route optimization. And it's using all those services that you mentioned. Lambda, API Gateway, Amplify Geo, and Amazon Location Service. So yeah, excited to jump into it.
Absolutely.
It's very cool. So normally when we create solutions like this, there has to be a problem, right? So what kind of problem is the solution seeking to solve?
Yeah, so we set out to solve one of the most basic optimization problems, which is the traveling salesperson problem.
Yeah.
A popular problem to solve in most computer science courses.
And I think you have a slide to share as well, right?
Yeah.
Okay.
Yeah. So here I've got a slide kind of outlining the problem that this demo sets out to solve. So starting from city number one, or node number one, the traveling salesperson problem tries to solve for visiting each city in each city in the matrix exactly once, and then returning to the origin. And we want to minimize the distance traveled to visit all of those cities and return back to the origin. So that's sort of the optimization problem and the constraints involved here.
Excellent. I think one of the inspiration to solve this problem for me was to crack interviews a long time back when I started the corporate world. But on a serious note, what inspired you to try to solve this kind of problem?
Yeah, so traveling salesperson is an NP-hard computational problem. You need optimization solvers. Thanks to Shreyas, we were able to find some good ones to use. But really what inspired us to build this solution out was the release of the Calculate Route Matrix API from Amazon Location Service in January of 2022. And what this API allows you to do is pass in an array of origin and destination points and return the route, or the distance or the duration of the routes between those points. And so this API sets up options to solve all sorts of optimization problems. And we're just starting to crack the surface with the traveling salesperson problem.
It's super interesting. I mean, it's awesome that you applied a traveling salesperson problem to this, which is figuring out the most optimized route. So in your solution, can you talk a little bit about what AWS services you use and why you have to bring in the host that kind of help with that? I mean, guests with that.
Yeah, absolutely. So at the core, we're using the Amazon Location Service APIs to return route information from our partners, Esri and Here. But the front end and the entire kind of workflow uses Lambda, API Gateway, and Amplify Geo to actually provide the front end maps and the layers on top of the map using Amplify Geo and the Map Libre library. So yeah, the API call is just sending point coordinates back to the Lambda function, which has performed the optimization, and then returning back the line geometry that's plotted on the front end map for the user. And we'll see that in just a second when we get into the demo.
Excellent. So I think there's a lot going on. We have Amplify Geo, REST API, Lambda, and the Amazon location maps. So we all are visual person, right? So you want to see all of this in action. And I'm very sure that we are not going to deploy this manually, right? So we must be using some automation to deploy this whole application, right? Okay.
Yeah. So the timing worked out great. This solution was just open sourced on GitHub under the MIT Zero license. And with it, we associated a SAM template. SAM is a serverless application model to help deploy with just a couple commands.
Yeah. Excellent. So for a few of our viewers who are new to SAM, SAM is one of our tool which you can use to deploy your serverless application, which under the hood uses CloudFormation, right?
Yes.
And this project, as Matt mentioned, is now open source, and it's there in our GitHub page, which I think Matt is going to walk through in a moment. So after this session, feel free to clone that and give it a try. Yeah.
Yeah.
So,
absolutely.
So why don't we jump into the demo and see all of this in action?
Yeah,
cool.
Let's see it.
Let's do it. So here's the GitHub page itself. As we said, it just went live 11 hours ago. And this includes all of the code and all the dependencies, as well as the SAM template needed to deploy the infrastructure on AWS in the back end. So yeah, without further ado, I'll just go through the steps to deploy this SAM package, and let's see it in action.
Yeah.
Awesome.
So I'm going to navigate to just a terminal here. I've created a directory, empty directory, and I'm going to git clone the repository. So grab this URL. Great. So now we've got our solution cloned. I'm going to cd into the directory itself. And now within this directory, what we have is an index root opt HTML file. It's not the cleanest name, but I tried to be a little bit descriptive there. As well as the template.yaml file, which actually includes all of the infrastructure as code directions that are going to be deployed as part of the SAM deploy command. So I'm going to run SAM build. And we're getting a notification here that we're using the serverless REST API. That's totally OK and to be expected. The reason is we're using this as an output of our stack so that we can then copy and paste it into the index.html file. So great, the build was successful. Now I'm going to run SAM deploy -- guided. And I'll be prompted with several instructions. And these are the input values or the parameter values that I'm going to give to the SAM deploy as it builds out my app.
So the next time onwards, if you have to do, we don't have to use the --- guided, because all these inputs which you are going to put now, it is going to get saved in a configuration file. Yeah.
Amazing.
Yeah, so I'm just going through and entering the names for these resources.
Yeah.
I want to be specific.
So for our viewers, if you're wondering what are these parameters are, you can open the template.yaml file to see all these variables. So these are basically placeholders or the variables which might be different for different users. So you might want to name your variables in a different way, and this all will get reflected during the deployment time.
Yeah.
And what's great with doing with a template is that you can change the front end, you can change the back end.
Absolutely.
So it's really modular the way that we created it.
One thing to point out here, the template does not have auth on the Lambda function itself. So you do have to explicitly with SAM give it the direction to allow no auth. So here I've just provided y no auth. And there we go. SAM is off and running.
Yeah, this is because this is for a demo purpose, so we are good for with have this authorization. But otherwise, in production environment, you might have Cognito or any of those services which can help you for authentication. Yep.
Yeah. So I think this will take a second to deploy. So while it's doing that, let's talk about how you solve the traveling salesperson problem. Because clearly that's a hard problem, and you applied it to this solution. What did you use to solve that?
Yeah, I'll let Shreyas discuss his solution. It was an interesting journey. We started using different packages in Python, and we finally came across one that worked for us.
Yeah, just to give viewers a little bit of a background, So the traveling salesman problem has been studied for decades now.
Yeah.
So it's an old problem, and you can see lots of researchers doing, advancements up to today. People using reinforcement learning and machine learning to solve it. But if you backtrack, a couple of decades, you'll see, people started solving this with just a naive way of kind of going through every possible permutation, right? So let's say you have 3 cities, A, B, and C.
Yeah.
The kinds of routes that you can explore there is if you start from A, it's either A, B, C or A, C, and B.
Using brute force.
Right.
Yeah.
So that comes down to like n minus 1 factorial, right?
Yeah.
Going back to a little bit of high school math here. But if n is a number of nodes that you're going through and you're starting off with 1 node, it's n minus 1 factorial. So that's why we get like 2 options for nodes of 3. But if you go up to like 8 nodes, that's about 40,000 permutations. If you go up to 10 nodes, it's about 3.5 million permutations.
Wow.
So let's say you take a millisecond to even evaluate one option. It's going to take a couple of hours if you're going more than 10 or 11 or 12 nodes there. So loads of research has been done on this. There's lots of heuristics-based solutions and machine learning and optimization-based solutions. What's most common, and viewers who are kind of in the know of optimization know that there are optimization algorithms that can quickly solve up to like 1,000 nodes.
Yeah.
And so that's why it's great. That's why you can use some of these back-end solvers, it's called. What we do in Lambda is we have an open source solver called OR Tools. And what that does is lets us formulate the problem as a routing problem. And we can solve it almost immediately, and you'll see that in the demo as well.
Super cool. Exciting stuff.
Awesome. It looks like our stack deployed successfully. So I'm just going to go into the CloudFormation console within AWS to just verify that that stack was deployed. Here I can see Remar's demo.
Wow.
And all of the output information as well. So we can go into the resources and actually see the physical AWS resources that were deployed as part of this SAM deploy. We have a location services map, a place index, a location services route calculator, an IAM role for the Lambda function, a serverless REST API that integrates with the Lambda function via Lambda proxy from API Gateway. As well as a Cognito identity pool to do unauthorized auth in this case, but it allows the option to add authorization later as well.
Very cool.
So great, we have all our resources. In the GitHub repo, which you'll see, there's a README file that has instructions on pasting the outputs of this stack into the index.html file. So real quickly, I can actually show how to do that using the outputs. Let me jump into the index file and we'll look at some code. So online, I'll scroll down here. This is all the Amplify prereqs at the top. On line 66 here, I'm going to delete the identity pool ID and grab the output identity pool ID from the stack itself and paste that in there. And I'm going to do this for all of these resources that are in the output of the stack. So that includes the region.
Yeah, and this seems like a very simple process. And like I said, it's outlined in the GitHub repository. So you can do this at home too.
Absolutely.
Yep.
Yeah.
I think we are missing the semicolon in line number 67.
Good call.
And for those of you who don't like looking at code and want to just look at the map as soon as possible, we'll get there in 30 seconds.
We'll get there in just a second. Yeah.
But we're coding live, though. That's the good thing, though.
Never an easy thing to do. So I'm going to scroll down and just I've grabbed the API endpoint URL, and I'm going to add that in so that I can send the data directly to our API that we've created backed by Lambda. As soon as I find the URL invoke, here we go, on line 184 here. Great.
All right.
So I've got these, I'm going to save that. And I'll navigate over to the file itself. So
Wow.
This is what the application will create for you on the back end. This is an Amazon Location Service map using Here Maps, which is one of the map provider partners for Amazon Location Service,
Wow.
along with Esri. And I'll start clicking, and this is basically going to demo how the optimization API works on the back end. So at the top here, we can optimize for distance or duration, and we can also select a travel mode. In this case, we'll stick with distance and go with car. So I'm going to input the first point, and you can see a response from the API. There was a little bit of latency, and that's because of Lambda cold starts. But it's much faster now that the Lambda cold starts are out of the way. And here we're already returning routes. As I continue to add nodes, what's being displayed here is the optimized path from the API that's using Amazon Location Service, calculate route matrix, and calculate route. So as I continue to select points, you can see the geometry will change. And the route is always starting at this point because that was the first selection, and being returned to that point as well. One of the things we're hoping to see from the open source community is to get some better labels. That's one of the first projects I'm hoping to add to this.
And these floating numbers in the list is like, I guess it's a longitude and latitude, right? The location points, right, that we can get. And we can use that for other things as well on top of it if you want to build something. Excellent.
Correct, yeah. And one of the other things this is doing is actually geocoding the coordinates that are being sent. So you'll notice that there's addresses returned in the output of the optimized path. So you could plug those directly into any sort of mapping solution or GPS solution to get directions.
Excellent. I think this is super cool, right? What we have deployed in just a couple of minutes, right? So I hope that you all get a chance to clone this repo. Can you just open the repo link so that our viewers can take a note of this? So it's under AWS sample serverless route optimization, right? So give it a try and share your feedbacks. So before we wrap up, I guess we have just 1 minute left. Is there any last thoughts that you would like to share to anyone who wants to get started with this?
Yeah, I think Shreyas and I, who worked on this project, are both really excited to see where the open source community can take this. And we're going to continue to add on and iterate on what we've built here. And we like to consider this sort of a modular platform for additional route optimization problems.
Absolutely.
Vehicle routing problem, for example, is kind of the next step here, and that's where we're hoping to take this. So looking forward to what's ahead.
Excellent. Yeah, sure. Thank you so much, everyone, for joining us. Thank you so much, Shreyas and Matt, for your time and sharing all of this with us. We will be right back in a moment. Stick around and have a wonderful day ahead. Bye.
Bye for now.